Right, next question here, lads, from page 22, question 6 this time. Slightly different question. There's no dihedral angle involved this time. What you're given is a square-based pyramid with a section sliced off it. Now I've just shaded in, so the red part here is the bit that's cut off. And there's a couple of questions based around that. The first thing is they're asking you to show the true angle of the cutting plane. So when they say the cutting plane, they just basically mean that shape that's left behind. What angle is that making to the ground? What's the true angle of it? So, like I've said before, it's a 3-point surface, 2 on the ground and 1 up in the air. So the simplest kind of description I could give of it is think of it as a set square. You have 2 points on the ground and you have 1 up in the air. And that it kind of looks like that cut surface anyway. If I'm holding that at a particular angle, it's at a slope against the ground, and that's basically what they're asking you to measure or to indicate. What's the slope of that cutting face against the ground? The simplest way of doing that is to get an edge view of it. And if you get an edge view of it, you'll see what angle it's making to the ground. When you have any surface that's touching the ground, the best way to get an edge view of it is just to look along the base of it. So we have 2 points on the ground. That means that line there is the base of that surface. So if we look up in that direction, we should get an edge view of that object. Again, I'll use the adjustable for this. So we set the angle against the base of that surface. We look up in that direction. We draw an x1, y1 line. We're just concentrating on that cut surface. We're not annoyed about any other part of the square pyramid, just that 3-point surface. So we bring up the base. They're going to be on the ground because they have a height of 0, both those points. The third point, bring it up. As always, go back 2 views, so your measurement's going to come from the elevation. Measure the height of it with your compass. Transfer it up to the auxiliary. And now we have our 3 points marked off. So we just label them. Say that's point 1, point 2, and we call the highest one point 3. When I'm looking up here, I'm seeing point 1 and point 2 as a single point because I'm looking along the line that they're in. Point 3 is up here. So if I join up 1, 2 and 3, I have an edge view. Now, the x1, y1 line in the auxiliary is the ground. So now I'm able to indicate whatever the angle is between the cutting plane and the ground. You don't actually have to go and measure it, just indicate it by putting in that little symbol. So that's the answer for part 1, that angle there. Or you could measure the inside angle, both of those would be correct. The second part of that then is asking for a true shape of that cut surface. So like I said, if your 3-point surface is sloped away from you, you're not seeing the true shape of it. Same as with like a line of intersection, you'll only see the true shape of something when you look straight at it, perpendicular. So we're going to look at the 3-point surface again, and this time we're going to go perpendicular straight up through it for a second auxiliary. It's the most straightforward way. There are other ways of answering it, but that's probably the simplest way. So again, we're going to base this off the ground line, point 1 and point 2, and we're going to look perpendicular against them for our second auxiliary. So we bring the 2 of them up, we bring point 3 up, create an x2, y2 line, and our measurements come from our elevation. So take the heights, mark them off. 1 and 2 are on the ground. Point 3 is elevated as shown. And you'll see that when you join the 3 of them together, you'll know you're getting a true shape because it's a lot larger than what it looks like in the elevation. It covers more area. And that's your true shape.